Welcome there, Internet, to another tutorial from beginningprogrammer.com on YouTube. So this time we're going to be talking about Java and data structures, creating a linked list. This time we're going to do it raw, we're going to do it live, and we're going to make mistakes, but we're going to figure it out, and we should be able to get it done in a short amount of time. So let's get started. So if you're not familiar with a linked list, what a linked list is, it's not that difficult to describe. Let's go ahead and take something. Let's take Paint program and let's just kind of draw it out. And it's the best I can do. I would really do need to find something better. If you have suggestions for something better to describe drawings, please let me know and I will look it up. But anyway, a linked list is composed of two things. So what is a linked list? A linked list is something like this. Let's start out with a rectangle, and let's just say a linked list has two things. And I know typically it's drawn like this, and then you draw another uh, thing, another cube here, and maybe draw a dot in the center of it, the little dot, and you have an arrow pointing to another thing here, and maybe you have this arrow, and let's use the triangle. Maybe that'll work. No, let's draw an arrow. Let's put an arrow here, the arrow, and it points to the next thing. So we take one of these, another one of these, and we copy it and we point it to the next one. How do I make this transparent? I don't know. Let me just cut it a little bit shorter. I don't want to waste a lot of time doing this. And so there you have a linked list. And so typically a linked list will have data, some kind of data. It can have as much data as you like. It could have names. It could have whatever. But this is a pointer, and it points to the next element in the list. And typically this is an address. But you don't worry so much directly with the address. You know it by name in your code. So for example, you have data here, and you have whatever data. You can have many different data elements, and then you have a pointer to the next node, and then it just walks its way down. So if you want to find your way in the linked list, you look at this data structure, and then you look at the pointer to the next, and you go to the next one, and you just keep moving your way down. So how do you do that? Well, first of all, this is a node. Anytime you have a node and you linked list is your graph, and you just kind of walk your way down. So how do you do that in Java? Let's take a look. Let's not close it, let's just minimize it. And so first thing in Java, you got to have a node. So let's start off with the node. So let's just say we have a node, and we have a class node. And then we have data. And let's make our data just be a string. And we can have it be name. Let's say, for example, we had a product. And we have a name. And then we have description or something like that. But let's not worry about description. Let's just have name. And we have the node. Now keep in mind you can put anything you want. And then we have another node, and we point that to next. So that's simply our node. And this node can point to other nodes. So if we were to link this node, we could say, for example, down here and say, we could call our node, and we could say list, and we don't even have to call it list. It kind of becomes a list, because just like a chain, the chain is not really a chain. It's all composed of links, but when you chain them together, it becomes a chain. You put all those links together and they become a chain. So you have a linked list. So you have the head, and you can set it to null. But then you could have your head and say head equals new head, new node. You instantiate it, and then you say head name equals Joe, and then you could say head next, and let's not use the lowercase, let's just say next here. So there we have next, and we could say we point it to null. But then we could create another one. Let's create a link. We call this node link. and we could say equals new node, and then we could take the head next equal to link. So now we have a link, and then we have head name. Oops, I'm doing C++ here. This should be Java, so we use dot notation. Dot next equal null, and there we have a simple linked list. Now we did it the brute force approach. We have the head, and we have, and you can see where we could do it, keep doing it repeatedly. Now we may not want to have that, so let's do something different. So let's say instead, since we have a class and we have objects, let's just go ahead and do the two strings. So let's do an override. And we have two string. So to string, what we want to do is just display what's in name. So we return name. And so if we were to say system.out, and we print the line, and we say head, and we say system.out head.next. So head next is going to point to the other node, so it should be able to print the string. So let's see if this runs, and we get an error: toString in node cannot override toString in object. Why not? Assign weaker access. Oh, and that is because we have to make it public. Let's try it again. And we have Joe and we have null. So why does our head have null? Because node link equals null, head next equals link. Head next, we set it to null. We shouldn't do that. I meant to write name here. Not. It should have been link next. Link next equals null, and link name equals John. So now head is a node, and head name equals Joe, and head next equals null, and node link equals new node, and head next equals link, and link next equals null, and link name equals John, and we'll print head, and we'll print head next, and Joe and John, and you can see that link will actually print out the same thing. And we can say link should print out the same thing as head next. And so we have John, but this is not the way you would want to do a linked list. Of course, there's some algorithms for that, so let's not do that. And let's go ahead and create a linked list. So let's just create something else. So instead of simply having a node, let's implement a linked list. So we can do this a couple of different ways. Sometimes you want to hide the abstraction of the list, and you don't necessarily want to display what you're doing with the list, so you would want to create a class called list. And so let's do that. So let's say we had a class called list, but we don't want to call it something that already exists in Java framework, so we just call it something else. So we'll call it my list. And so this is our class. And whenever we want to add to our list, we just say, we'll add, and then we just give it a value to add, because we have a list of names. And my list can have a node, that's the head, and that is internal to our list. And here we can say, for example, if we have head, we can say add, and we say if head equals null, and we can assign head, and we can create a new node equals new node. And to save us some grief for initializing our node, we can create a constructor for our node, and we can say public node, and we can initialize name equals an empty string, and next equal to null. And that way we know we have a good starting point. So now we say head equals node, and since we have constructor capability, we can even go one step further and say public node and give it the name string name, and we can say this dot name equals name, and we can have this, and now we have name, and we can make these private. So let's keep these private so we don't access them. We don't provide access to them. And when we want to point it to the next node, we can just simply pass in the node. We can say public, and we can say void, and we can say set next, and we pass it the node. And we pass it next. And sometimes we may want to set null. So there we have our node, and we can set it. So now when we add to the list, we say if head equals null equals new node, and we set it to the new node. And since we already have a constructor for it, we can say name, and it will be pointing to null. Now if the head is not null, we could walk our list, so we search for the insertion point, so we go and get the tail. So we can say get tail, and we can walk our way from a given node. We say get tail, we go from the head, and we say node equals get tail, and we will find something because we know something is there. So now we say node, and in order for us to set node, right, so we have the node, and we can set next. We can say set next, and we can create a new node with the name. And that'll point us to the new node, and that's all there is to that. So how do we get tail? Well, we have to walk our way down the tail. So we say, we make it a private. We say get tail, and it returns a node, get tail, and we receive a node for the head. And we can say simply have a pointer of node. We can say tail, and we can say, since we have the tail, we can say tail equals head. So from here, it's just a matter of walking the tail. So we say tail equals head, and we can say while tail, not that again. And since we made next private, we have to have a way of getting the next, so we have to provide that. So we return next. We know that next. So when we set this next is set to null here, so we have to also set it to null here. So we say next equals null. And we change name to lowercase, so we gotta make sure we set these properly. So there we have name and we have next. That's our node. Okay, that looks right. That looks right. And this is not right. And next equals next, get name. And of course, we're gonna need a way to get the name out of node because we need access to that. So we can create some more getters and setters for node. And this time we say set name, and we have a string, we have a name, and we say name. This dot name equals name, and get name simply returns name. And that looks right. So my list now has a way to add nodes into it, and we're gonna always add to the tail. So we add a name, and we add node, name, get tail, head, set next, new node, right? So we're in the process of getting the tail, so we can say while tail dot next. Oh, we have to say get next not equal to null. So we're walking our way down the tail, and we say tail equals tail dot get next. And we are simply going in this order. If we say this, we're saying in order to get the tail, we come to the head, and we say while tail is not next, not equal to null, so it means it's not equal to null, so we go to the next one, and this becomes our tail. Now we say while tail not next, not equal to null, but we know next points to null, so this is our tail, and that's what we're going to return. So we return our tail at this point. And this is, got to be careful with this. We probably don't even need this since we have an object, and let's just do get tail like this, and so we won't confuse it, and we don't need to pass this parameter here. So we have tail equals head while tail get next equals, but notice here that one of the things that we have to do is when we get tail, we also have to check now if we don't have, if it's null, we don't do it. So in this case, we can say while tail not equal null, and tail not next, get next not equal null, because we have to make sure that it doesn't have a null pointer here, a null reference to the tail. So we keep getting it, and it returns tail. Now in this case, if the head is null, which we're not initializing here, and we have to initialize our head to null. So while our tail not equal to null, we return it, and it may actually return null when the head is null. So we can return tail here. And so when we add, in this case, we don't have to worry about checking for null because we check the head, so we know it's not going to be ever null, so we're going to get something there, so we're adding there. Now, if we want to walk the tail, if we want to get the items in the list, we can say let's say we want to display that. Let's say we want to display the items in the head, so we would in the list, so we can say void display, and simply we can do something like this: node temp equals head, and we can say, let's scroll down a little bit, while temp not equal to null, temp dot next so we have to say temp set next, and we say temp get next because we wanted to set it to the next item. So now we say, well, temp not equal to null. We say temp set next, and we're passing it temp get next because we're getting the next pointer, and it may actually be null. So in this case, actually, this is wrong. We don't want to do that. We want to set temp equal to get next. So we walk the list so we get next, and it's walking its way down the list, and we want to display what we have here. So we can say system.out and maybe we want to have something like this so we can have the value in temp. And since we already have a toString on the nodes, it's going to display the name. So there's our list, there's our head, there's our add, there's our display. Let's make add correct here. Let's make sure we have followed good standards. So add, display, get tail. And so we have tail here, and we display. And this is just going to walk temp. It's going to go to next. And so it's going to display everything until it reaches null, and then it stops displaying. So when we have our list, we can have our list here, and we can add some values. So let's do a for loop. Let's not even do that. Let's just create our list. We create a new instance of the list. We'll say my list. And we can simply say list.add, and we add a name. We just add a series of names. So we say add, and then we can say what's more name. Let's think of a name. Let's say Mike, and we can simply say list display, and it should print our list. Let's see if we get any errors. And we have several errors. So what are our errors? Let's start with the first one. Java 12 error, cannot find symbol this.name. So because it's on line 12, because name is lowercase. And what else do we have? Error, incompatible types, return value, return this next. And that's Java 26. So let's look at 26, void get next. Oh yes, we have to return a node. And what else do we have? Let's see, incompatible types, void temp get next 58. What does it complain? What does it complain about in 58? Temp get next. Well, we know that that has something there now. 69 void type. Let's try and run it and see what errors we get now. So 34 incompatible types. Line 34. So this has to return a string. And you see that it prints out our list, displays it. Well, one of the things that you may want to do is get the entire list. You may want to get the list and do something with that list because you actually want the whole list. What if you wanted to walk down the list and get each item? So maybe you want to be able to get an item by index. So let's say you wanted to get John or Mary or Jesse by index. So how do you do that? So that's another thing where you have to walk the list. So let's go ahead and walk the list. So let's say, for example, we had a public method. Let's put it up here with the publics API. And we have public. And we want to return a string because we want to get the name, for instance. So we just have a get, and we give it an int, and we give it an index. and let's say we want to get a name. So what do? Well, what we can do is walk the tail just like we did for display. We can do the same thing as we did here, and we can walk the list. And we can say, for instance, index equals 0. And this time we're not displaying anything. We're just simply counting. So every time we get next, and we can do a comparison. So we say if temp, we're not doing a comparison. We are actually doing what we are doing in this case. We are returning the index. If index equals index, we can return the value in it. So we can return temp dot get name. And of course, we have to increment our index every time we go. So for example, if we start at 0, and every time we move, we advance to the next, we say I++. And so that'll give us something out of our index. So let's go back to our index, and let's try to get and see what we should return. So let's say that, for example, here we say list. We do a system.out. And we're going to do a simple test, get the head. So we're going to get Joe. So we get Joe, we know Joe. And let's see if Joe comes out. So we do list.get, and we get 0 because Joe is the 0th item in the list. And let's do another one. Let's do the last item in the list. And slash in get Mike, and plus list dot get, and what item is Mike in the list. So 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4. So we get Mike, and we want to get the 4th item, and let's see what it does. And we have index. Okay, what did we do wrong? We have index, but we have I, so we're inconsistent with our name. So we say index. Let's run it again. We have index equals 0, and it's complaining index is already defined. Oh, because we have this. Okay, so we do need I instead because we can't have the name. So we have to say if I equals index. So we increment I. So we have I to keep our count, but index is what we're comparing it against, and we return. What happens when we don't have anything here? We don't have a return statement for this. So we return there, but we're not returning out of here, so we have to return something. Now, at this point, if we didn't reach it, if we couldn't find the index, we could return, throw an exception, or we could just return something. We can return null, which would probably be a lot better than returning. We return null because there's nothing in there. So let's go ahead and do that. Got Joey, got Mike. But what happens when I do this? What will happen when I try to do a system out print line on the list and get something that doesn't even exist, right? So let's say I want to get something get unknown. Get unknown out of the list, and we give it an index that is not even correct. So we give it an index, for example, like 5, because we know we don't have a 5, 0, 1, 2, 3, 4. So what is it going to return? And it gives us null. So that's what it's supposed to do because it doesn't have anything in the list. We went out of bounds. A lot of times these lists return, I actually throw an exception when you have that. So what if we wanted to extend our list and we wanted to find if it contains something? Well, if it contains something, we could further do our list something like this. Well, let's put it in as part of the public API. So let's say, for example, that we wanted to say public, and we say Boolean contains. What if we wanted our list to contain something and we're looking for a particular string, and we say name, and we can simply walk down the list, and we walk down the list the same way we walk through it here. And we walk through every item in the list. We don't need the index this time, and we don't need this. We don't need to compare here. We don't need that. We don't need the I++. The only thing we need to do at this point is we compare it, and we can say if name that equals, and then we want to compare it to temp dot get name. So the first thing we want to do, maybe we want to check to see if it's null. If it's null, maybe we want to return something. That's something that you have to consider. So here we're just comparing it against name, and we can return true. And if it doesn't find anything, we can return false. So there we extend our list. So we have our list, and we can write a test for that. So we say contains Joe list dot contains, and we can say Joe, and then we can say list contains Mike, and we can say Mike, and let's see what it does. Let's see if it builds. We have an error. Okay, return true expected. So that we did, I probably left out my, oh yes, I did. I left out my semicolon. And contains Joe true. Oh, we don't say get Mike, contains Mike. So we do that, we run it, and contains Joe true. What if we pass it something that it doesn't contain? So let's see. Okay, this contains Mike, and let's see something that doesn't contain Joe, John. Okay, let's say Danny. Let's look for Danny, and it should return false. Okay, and I know it's hard to read this. Let me expand it a little bit so you can see that. And so maybe I can split these up so you can see them better, like this. Let me bring this back around. I know it's kind of hard to read with the REPL IT like this, so let's just say like this and like this, just to separate this. So that should return false. Though this video's gone long enough, I did it raw. I hadn't practiced this or anything, so I just kind of went with that. But you can see the process of a linked list. Normally, when you implement a linked list, you want to hide the implementation details. So you don't want to reveal node and next and all of that. Your list just simply implement the linked list, and then you abstract that information out. Let's say that in some case you may actually want to copy a list. You can get the idea of how you would copy a list, or how you would do contains or gets, or maybe you want to do something else with it. What is something that else that a list can do? A lot of times you can get the count Now, since we have the advantage with object oriented in something that is harder to implement in a procedural language like C, is that you have the count. So you can actually keep count of what's in your list. So you could say, for example, this. So you could say count, and you could say integer, and you could say count equals 0. And every time someone adds to the list, so you add to the list here and you add to the list here, well, you know, anytime you add, you increment your count, and you could say count plus plus. So you may want to have a count. So why is that important? Well, let's put it not in the private section. Let's put it here. And typically in Java, you use size. So you would say something like this. So you say size, you don't say count, and then you simply return the count. At that point, you have the size. So what you can do with the list, you can implement a count. So if you wanted to, you could go through your count like this in your list. So you could say for I equals 0, I less than list dot size I plus plus, and you could say list get, and you could say I, right? Because you know you have for the get, where's our get? Let's get tail. We don't want tail. Display. We have our get here, so we can get the item in the list, and we could simply do a system out. And we could say something like this plus I. So we could say list I. And let's separate it so we can see it better. So we say list I is, or we could say list get, because we don't have the overloaded index operators. So we could say list get I, and we can display what it is, and then we can iterate through our list. Let's put a system out here so we can so we have the list contents. I have an error, so get I did something wrong. Okay, I didn't close my print, so I can close it like this. And there it is, list contents equals that, and you can keep adding. What if you wanted to remove an item from the list? Okay, so the linked list allows you to remove, so that can get a little bit trickier. And normally this is where I would say, I'll leave it up to you, but I won't leave you hanging like that. Let's say we wanted to remove an item from the list, and since we have add, let's put it next to add. So let's say public void remove, and we would want to tell it what index to remove. And so we do that. And now we have to make sure if index is greater than or equal to 0, and index, and this is another reason why you want count, index less than count. So we know we're within range. So then we start walking the list. So we can say node temp equals null. Well, let's say node temp equals this dot head. And so we can say while temp not equal to null. And in reality, we could get the item there, but what we have to do, for instance, since we already can get items within the index, we don't even have to do this. We could simply say get. So we can say if item is a special case, if item equals 0, right? So let's see if they pass a 0 and it's greater than 0, but it's less than, because maybe we have a 0 count, then it wouldn't execute this. So let's say if index equals 0, it's a special case because that's our head, right? So we're going to remove the head. And so now we have to point head, right, to head dot next. So now the head is gonna equal to head dot next. So we say get next. So now our head is gone. We don't have to worry about garbage collection like we do in other languages. So we just point it to the next. So the head is gone, and we reduce our count minus minus. But what if it's not? Then we can simply get, if it's not 0, what if it's the tail? So if index, this is another special case, if the index is equal to the count minus 1, let's put it in parentheses because I prefer it for readability. So if it's equal to the count minus 1, then we're removing the tail. So at that point, then we don't have anything pointing to the tail, so we can actually get the tail. So we can say get tail, right? But we need the item prior to that, so we don't have to say get tail, and we really can't say get because we're returning strings on our gets. So we can walk it, or we can get the node, right? We can get the node next to the tail. So there's a lot of different ways you can do this. We can implement this here by saying node. Oh, we already have temp. So we have temp. So we don't even have to do this. Let's just walk it. So we want to get to the previous, so we can say while temp, right? And we know it's not null because of the count, so we say while temp get next not equal to null, right? While temp get next not equal to null. Now when we get to temp and the get next is equal to null, then we know we reached the end. But at that point now, we're pointing to the tail. So we want one prior to the tail. So we can say node previous equals temp, right? And so what we can do here is previous. Every time we said temp equals temp get next. And excuse my syntax because I'm been jumping between C, C++, and Java. So we get next. So we get next, and at that point, so we get next, but before we get next, we said previous equals temp. So temp, previous is always going to be pointing to temp. And so we can say temp, now we have this, and we can point previous, right? And so if we're removing index here, for instance, we need to know the index that we're removing. So we can have the index, we need an integer. So we have integer I equals 0. And we say I++. So do we do the I plus plus there, or do we do it down here? So we go here, I plus plus. So then we can say if, right? So at this point, we can say if I, because we could be in the one that we're looking for. We already removed 0, so we don't say, so if it's 1, then we need the previous. So we can say if I equals index, and I think this is right. So say if I equals index, then we know we're there. We know where we're supposed to be. So at that point, we would break out of the loop, because we have the index and we have the previous. So for example, if it was on the head, we would be on the head. It's never gonna be on the 1. It's not gonna be on the head. It's not gonna be on 0. It's gonna be on, at least on 1. So at that point, previous is going to now point to the next guy. So we break out of here. So we have previous, we have temp. So now previous dot set next. So previous set next, and we're gonna bypass temp. So we're gonna say temp next, right? Because previous set next, we don't want to point it to temp. We would say temp. That would keep us at the same place. So we say temp dot get next. And now we've broken the link, and in reality, garbage collection can pick up temp, and then we can say at this point temp to null. So we can do that. In this case, when we said head equals get next, we can say head equals null, and garbage collection will pick it up. There's no more references. So we have that there, and we remove the index. Now let's see if it works. So let's think about this for a second. So we have previous and equals temp. Previous and temp are both pointing to the head. So we want to point to next. So previous equals to temp. Temp points to head. They both point to head. If there is next not equal to null, we don't necessarily want to do that. So let's think about that one. If we have a node, so we have previous equal to temp, and while temp get next. So if we're on the second item, let's just kind of draw it out. We have an item, and let's say we have 0, 1, and it points to 1, 2, and this points to this is 2, and it points to null. And so if we're here, we're right now pointing both of them to the head. But so right now temp get next is not going to be equal to null. So it's going to go in here, and it's going to go in here. And I has not incremented. We are here, so the index is not gonna increment, so it's not gonna break. So now we point previous equal to temp. So previous is still pointing to the head, and temp now points to this guy. So temp is pointing to next, pointing to this guy. Previous is pointing here. Temp is pointing here. So then it's going to go, and it's going to get next, and then temp is now going to go point to temp. Temp is pointing here, so temp is pointing to next, and it's not equal to null. So temp get next is not equal to null because it's pointing here. This one's still pointing to this one. So we're pointing here, temp is pointing here. and temp goes in an increments I. So now temp is pointing to this guy, and it's not pointing to. So let's go back through it again. Let's say the first time they're both pointing here. Get next is pointing here. So index is not equal. Previous points to temp. So temp is pointing here. Temp get next is pointing here. We increment the I. So I is on this element. Temp get next is pointing here. It's still not on that element. It's pointing here, so it still goes in. It doesn't break because we're not equal. What if we were equal? What if we were deleting this guy? It would break. And temp was pointing here. So now previous is going to set temp and temp equals next. So that case works. What if it was the tail that we were pointing to? Previous would be pointing here, and temp would be pointing here. Now temp get next is pointing to null, so it breaks out. Previous is pointing here, so previous set temp equals temp get next, which is going to be null. So it should be fine. This should be fine. This should work. So let's take a look. So we are going to remove. So let's try removing something. So let's say, first of all, let's remove the tail. Let's see if it works. Let's remove the tail. Let's remove Mike, which is 0, 1, 2, 3, 4. And we want to remove item number 4. 0, 1, 2, 3, 4. We want to remove 4. And we display the list again. Let's do a system.out. Let's run it. And it didn't remove Mike, it's not pointing to 4, and the size is telling us that it's got 4. So what didn't we do? When we remove, we have to decrement the count, because we decrement the count there, but we didn't decrement the count here. So let's do that. And so if index equals 0, we remove the count. So if we actually remove something like we do here, maybe at this point we should return, just to be safe. We remove and we return. And then down here, if we get all the way down here, we decrement the count. We know we should be removing something anytime the index is within bounds, so we know we removed something. So let's run it again. And now it gives us the right number, so we're removing from there. So let's add Mike back in after the removal. Once we remove Mike, let's add Mike, or we can just go ahead, since we have enough. We have 0, 1, 2. Let's remove from the head. Let's remove the item 0. So let's copy all this code. Let's remove item 0 and see if the head removal works. And let's take a look. If we remove, after removing Joe, let's remove Joe. And after removing Joe, we do have Joe, and Joe's removed. And let's remove Mary, because that's something in the middle. And Mary is at item now 1. let's remove Mary, and Mary is at index 1. So we can remove Mary, and let's see if that works. Mary has been removed. Now let's just go ahead and remove the last two. It should still work. Or what if we remove something that's not there? Let's remove item 2 after removing out of bounds index. Because we don't have anything in item 2, what happens there? And it doesn't remove anything. It's still there. So let's go ahead and remove now item. And let's remove item 0 twice to make sure that we can remove from an empty list. Remove 0 and not remove 0, because that's going to remove 1 and it's going to remove the other one after removing all. And let's run it. And there's the list. So there you are. There you have the list. And let me do something really quickly here. I'm going to save it. I'm going to title it Java linked list. And I'm going to share it, and you can see the share. You can see this. And that's kind of hard to read, but it'll be on the video. So let's go ahead and paste it here so you can get a better view. Uppercase F, lowercase L, lowercase. So the first letter is uppercase, and then that's, so, and we just save it. And if we were to share it, it's a 1. So the next one would be 1, the one with this link. So in actuality, we don't want that. So let's just save it. And if we were to share it, it would be 2. So you want the 2 because the other one's not going to build because I had the error there. So we run it, and there's your linked list. So if you enjoyed this video, if you learned something, give it a thumbs up, like it, subscribe. I got more videos coming your way. I do a lot of these videos from questions that come in. So if you ask me questions, I will post a video and it'll help you, and hopefully you learn something. And like I said, if you like it, give it a thumbs up. Go ahead and subscribe. Thanks for watching.